Welcome to the Explainer. We're surrounded by rules, speed limits, budgets, you name it. Today, we're going to decode the secret visual language that defines all of them. It's a simple tool from back in school that once you see it, you'll start seeing it everywhere.
All right, so let's just jump right in with a question. Think about a rule, any rule, like the speed limit on the highway, or maybe an age restriction for a movie. How would you draw that? How could you show the entire rule on just one single line? Well, the answer is something called inequalities. And the key to making them make sense visually, it's a tool you definitely already know. It's the good old number line.
Okay, so how do we decode this thing? It's actually super simple. It really just comes down to two key ingredients. You've got the symbols, which tell you which way to go, and then you've got the dots, which tell you where to start.
Now, the symbols are pretty straightforward, right? Less than, greater than. They basically just point the way. They give you the direction of the rule. But the real magic, the part that makes this whole thing so precise, is how we mark that starting point. And that, right there, leads us to the big question for any rule. When you set a limit, like no more than 10, is 10 itself okay or not? And the way we solve this is with a really clever, simple visual trick. It's all about whether the dot is filled in or not. And this is it's so elegant, right? A filled-in dot, a closed circle, means, yep, this number is included, it's part of the deal. But an open circle, that means the number is just a boundary. You can get right up next to it, infinitely close, but you can never actually land on it. Okay, theory is great, but let's see this in action. Let's start with a classic example, setting a no more than kind of rule. Imagine we're setting a limit for a long journey. So the rule is pretty straightforward. 10 miles is the absolute max. You can't go over it. That means any distance up to 10 is fine. And here's the important part, including 10 miles itself. That little word, including, is the key. So, in math speak, we'd write this as x is less than or equal to 10. That little x is it's any distance you might walk. And when we draw this out, the whole rule just snaps into focus. And there it is, the whole rule, clear as day. See that closed dot on the number 10? That tells us walking exactly 10 miles is totally okay. And the arrow shooting off to the left, that covers everything else that's allowed. 9 miles, 5 miles, even half a mile. Anything from 10 on down. All right, so that was a ceiling. Now let's flip it around. Let's talk about the opposite, a floor, a minimum requirement that you absolutely positively have to meet. So now the logic is totally flipped. We don't have a ceiling anymore, we have a starting line. 5 miles is the bare minimum to stay on track. If you do anything less than that, you're falling behind. And the math for this, just as simple. X is greater than or equal to 5. And the picture tells the exact same story. That closed dot at 5, that locks in our minimum. Then the arrow points to the right, opening up a whole world of possibilities. 6 miles, 10 miles, 100 miles. As long as you hit that 5-mile mark or go beyond it, you're good to go. Okay, so we've done a ceiling, we've done a floor. Now for the really cool part. What happens when you put them together? You get this perfectly defined window of what's allowed. So here, both rules are in play at the same time. We have a clear minimum and a clear maximum for the day's journey. This little piece of math is called a compound inequality. I love this because it perfectly boxes in our x. It's basically saying, hey x, you have to be bigger than or equal to 5, and at the very same time, you have to be smaller than or equal to 10. And when you draw it, it's just so intuitive. You've got a closed dot at 5, another closed dot at 10, and you just connect them with a line. That little chunk of the line, that's it. That's the entire universe of what's okay. This whole visual language isn't just for showing rules that are already clear. It's great for solving problems, too. Look at this. 2x is greater than 10. Okay, what does that really mean? Well, if we just do a little bit of simple algebra, divide both sides by 2, we get a super clear answer. X has to be greater than 5. And now we know exactly how to draw it. We use an open dot at 5, because 5 itself isn't included, and then an arrow pointing to everything bigger than 5. Okay, let's zoom out for a second. Why are we even talking about this? Why is this simple little tool actually so powerful? Because this goes way, way beyond a math class. This is like a universal language for limits. It takes these fuzzy, abstract ideas, think about a project budget, or the safe temperature for an engine, or a dosage for medicine, and it turns them into a picture a concrete picture that anybody can understand in a split second.
And at the end of the day, that's what this whole thing is. It's a picture of what's possible. On one simple line, we can show exactly what's allowed and, just as important, what's off limits. So I want to leave you with this question. Think about a rule in your own life. It could be your monthly budget, maybe your daily goal for screen time, or even just the speed limit on your street. What does the number line for that rule look like? Is the dot open or closed? Which way is the arrow pointing? Because I'll tell you what, once you start seeing the world this way, you can't unsee it.